When you open your laptop, you expect this invisible contract to be honored.
Oh, absolutely.
Like the screen lights up, the engine purrs, and your files are exactly where you left them. You really do not want to think about the thousands of interlocking software gears turning underneath the keyboard just to show you a mouse cursor.
Right. It is a completely fragile illusion. I mean, we demand that our technology feels organic and instantaneous.
Yeah, it has to be immediate.
Exactly. But beneath the glass, it's heavily mechanized.
Yeah.
And honestly, constantly on the verge of breaking.
And when you peek under the hood of a major operating system update, you realize your daily digital life is, well, it's sitting on top of a massive, constantly shifting construction site.
It really is.
And that is exactly what we're looking at today for this deep dive. We are exploring a remarkably detailed, hands-on blog post published on April 25th, 2026 by a tech enthusiast named Eng.
Yeah, Eng just made the leap and upgraded to the newly released Ubuntu 26.04.
Right. An operating system release affectionately codenamed Resolute Raccoon, which is just a great name.
It is a fun one.
Our mission today is to show you that a deep dive into an OS update isn't just, some dry technical changelog.
No, not at all.
It's a real-time exploration of how the digital tools we use every single day are evolving right beneath our fingertips.
Which is super important to understand.
Yeah. We are going to explore everything from the sheer anxiety of trying to attach a file without your computer crashing all the way down to the intense hardware demands of running your own artificial intelligence locally on your desk. Okay, let's unpack this.
Setting the stage here, what really stands out when you read through Eng's upgrade experience is this overarching theme of polish and preparation.
Polish and preparation, okay.
Yeah. This Resolute Raccoon release represents a true foundational moment. It's an operating system that is trying to bridge the gap between the legacy computing of the past and the extremely demanding AI-driven desktop of the future.
To really see that bridge, we kind of have to start right at the surface.
Right, the user interface.
Exactly. You boot up the new OS, and the immediate user-facing experience dictates your entire mood. I mean, before you ever open a terminal or write a line of code, you have to look at the screen.
And Eng's overall impression is that this is a rather polished release.
Yeah, they specifically note that GNOME 50, which is the visual desktop interface, feels exceptionally smooth.
Which is huge. Smoothness at that visual layer is paramount.
Right.
I mean, the desktop environment is the translation layer between human intent and machine execution.
So if it lags, it feels broken.
Exactly. If a menu stutters when you click it or an animation drops frames, the user feels this microscopic jolt of frustration.
But that translation layer isn't flawless yet, right? Eng points out a very specific, incredibly relatable pain point.
Oh yeah, the Nautilus crash.
Yes, they mention really hoping that this smooth new GNOME 50 update finally fixes a notoriously annoying crash in Nautilus.
Which, for those who don't know, Nautilus is the default file manager.
Right. And the crash happens specifically when opening the file picker dialog. Think about that from a user's perspective. It's infuriating.
You're just trying to upload a photo to a website or attach a PDF to an email. The file picker window tries to open to ask you which file you want, and boom, total crash. The application just disappears.
It completely shatters that illusion of stability we talked about earlier. It halts your workflow dead in its tracks.
It really does.
Yeah.
But why is a simple window asking you to pick a file so difficult for the computer to handle?
It seems simple, right?
Yeah, it feels like the most basic function of a computer.
Well, it's actually a massive intersection of different critical systems colliding all at once.
Oh, really?
Yeah. When you click Attach File, the system has to simultaneously render the visual user interface, query the physical hard drive for an index of thousands of files, read the metadata to generate little thumbnail images of your photos.
That's a lot happening at once.
And verify your personal security permissions to make sure you are actually allowed to see those files.
Wow, okay. So if any one of those threads trips over another, say, the hard drive takes 1 millisecond too long to read a thumbnail, while the visual layer is expecting immediate data. The whole application panics.
And it closes itself?
Exactly. It closes to prevent memory corruption.
So it's basically a multi-car pileup just behind the screen.
That is a perfect way to put it.
But in the very same paragraph where Eng is lamenting this surface-level visual crash, they pivot and start talking about the absolute deepest plumbing of this system.
Right, moving from the UI to the kernel.
Yeah, they are actively evaluating the brand new Linux kernel 7.0. Aang is digging through the system logs to see if this new core engine finally provides the fixes needed for a specific piece of hardware.
Their MediaTek 7925 Wi-Fi adapter.
Right, and the kernel is essentially the foundation of everything.
It is the literal translation manual between the operating system software and the physical silicon of the chips inside your computer.
So if the manual is wrong, nothing works.
Exactly. If the driver for that MediaTek Wi-Fi adapter is flawed, the operating system simply does not know how to tell the physical antenna to listen for a signal.
It feels exactly like moving into a newly renovated house. GNOA 50 is the fresh, smooth paint on the walls.
Looks beautiful.
Yeah, it looks amazing. It feels great to run your hand over it, unless you lean against the wall and the plaster cracks.
Which is your file picker crashing when you try to send an email.
Exactly. But kernel 7.0, that is the plumbing buried deep inside the concrete foundation.
The stuff you never see.
You never actually see it, but you are really, really hoping the pipes that connect your Wi-Fi adapter finally work without leaking water everywhere and dropping your internet connection.
What's fascinating here is how these two extremes, a crashing visual element and deep kernel-level hardware drivers, completely dictate a user's trust in an operating system.
Because the user experiences both as just the computer being broken.
Exactly. You can have the most advanced, perfectly optimized kernel in the world, allocating system resources, but if the user's file picker crashes when they try to save a document, they're going to conclude the entire system is broken garbage.
They don't care about the plumbing, they just see the peeling paint and assume the whole house is a teardown.
And conversely, if the interface is gorgeous and never stutters, but the Wi-Fi keeps dropping because the kernel can't properly talk to the MediaTek adapter.
Well, the house looks beautiful, but you literally cannot live in it.
Right. Ubuntu 26.04 is clearly trying to shore up both ends of that spectrum simultaneously. Polish the paint, fix the pipes.
But a stable file picker only gets you so far, right? To actually control what the machine is doing, to change how it behaves, you have to bypass that visual layer entirely and open the terminal.
Which moves us from the visual interface to the beating heart of the Linux experience, the command line utilities.
And for this release, Aang highlights a massive change in a tool they use regularly, the apt package manager.
A staple tool for any Linux user.
Yeah, this is the text-based tool you use to install, upgrade, or remove software on the system. And it just made a huge jump from version 2.7 all the way to 3.1.
A major version bump of that size implies a significant architectural shift, not just a minor bug fix.
It definitely added some new flavor, too. Aang points out that the help message for apt now claims it comes with, and I quote, super cow powers.
Gotta love that.
A classic bit of developer humor baked right into the system. But beyond the jokes, Aang notes that the commands for package installation are now much more refined.
And there's a huge new feature in there.
Yes, the absolute standout feature Aang's favorite part is this highly anticipated apt history list command.
This is a profound shift for system administration and everyday tinkering.
It functions like a literal time machine for your terminal. Aang explains that you can now see your historical installations and actually redo or undo them.
Which is a lifesaver.
Think about how many times you followed a tutorial online, installed some random package to get a game to work, and it pulls in 30 unseen dependencies.
It completely breaks your system.
Yes. It changes your configurations, and suddenly your computer's audio stops working completely.
We've all been there.
You're just sitting there sweating, trying to figure out how to manually rip it all out and put everything back the way it was.
Now you can just look at the history and hit undo.
It's magical. Aang even shares a snippet of their own terminal log, showing a track record of unattended upgrades, auto moves, and dist upgrades.
Which, for context, are the major commands that handle fundamentally changing the underlying architecture of the system.
Exactly. But I actually have to push back on something in that exact terminal snippet Aang shared.
Please do. What stands out to you in that log?
Right at the top of the apt history list output, there is a glaring all-caps warning printed by the system. It says, "Warning, apt does not have a stable CLI interface. Use with caution in script."
Yes.
First, let's clarify that CLI stands for Command Line Interface. But more importantly, if this tool is now a highly sophisticated time machine with undo capabilities, why the strict warning about using it in scripts?
Seems counterintuitive.
Right. Isn't scripting, which is just automating repetitive tasks, exactly where a power user needs stability the most?
That is a very perceptive catch. And it fundamentally comes down to understanding the difference between interactive user tools and automated scripts.
Okay, lay it on me.
Apt is designed for human eyes. It is designed for you, sitting at the keyboard. It provides those super cow powers. It gives you colorful text, dynamic progress bars, and helpful human-readable prompts.
Which is great for me.
But when a system administrator writes a script to automate the setup of 50 servers at once, they absolutely do not want human-readable output.
What do they want?
They want predictable, unchanging, strictly formatted, machine-readable text.
Because the script is just a robot trying to read what the program spits out.
Exactly the issue. If the developers of app decide to change how they space a column or add a new warning message in version 3.2, and your script was blindly relying on that exact text formatting to trigger the next step,
Your script breaks.
the automation fails completely. So the warning is there to say, look, this tool is for humans. For scripting, you should use lower-level, rigidly stable tools that output pure data instead of pretty formatting.
Ah, okay, that distinction makes perfect sense. The tool itself is stable for me to use, but the text it displays isn't guaranteed to stay the same for a robot trying to read it.
Precisely.
And that commitment to strict foundational stability is actually driving the biggest hidden change in this Resolute Raccoon release. Ang notes that Ubuntu is actively migrating its console utilities to Rust.
If we connect this to the bigger picture, this cannot be overstated. It is a monumental shift in operating system design.
Ang specifically mentions tools like sudos and Rust core utils. They point out that these Rust-based tools are getting polished right now ahead of a full, complete switch in the upcoming 26.04 release later in the year.
For decades, legacy utilities like sudo, which is the command that grants you absolute, godlike administrative privileges over the system.
Kind of important.
Very important. And the cur utils, which are the fundamental commands that allow the system to move files and allocate data, have been written in the C programming language.
And C has been around forever, right?
Yeah, C is incredibly fast and powerful, but it requires the human developer to manually manage memory.
How exactly does a programming language cause a security vulnerability?
Well, in C, if a developer wants to process an image, they have to manually tell the computer, allocate 5 megabytes of memory, and then when they are done, they have to manually write the command to free up that memory.
Okay, seems straightforward.
But humans make mistakes. If the human forgets to free it, the memory leaks.
Oh, I see.
Even worse, if they accidentally allow 10 megabytes of data to be pushed into that 5 megabyte space, the data spills over into other parts of the system.
Yeah, it sounds really bad.
That is called a buffer overflow. Hackers intentionally trigger buffer overflows to inject malicious code into the computer's memory. It has been the root cause of countless catastrophic security vulnerabilities for half a century.
It sounds like an airport security checkpoint where you just trust the passengers to walk out onto the tarmac and find their own plane.
That's a great analogy.
In C, you're just hoping the developers do the right thing. But Rust changes the architecture of that checkpoint.
That is a brilliant parallel. Rust introduces a concept called the borrow checker.
So the borrow checker is the TSA agent.
Precisely. The borrow checker evaluates the code before the software is even compiled and built. It treats memory allocation like a strict system of library books.
Checking them in and out.
Exactly. Every piece of memory must have one specific owner, and it can only be borrowed under strict rules.
So what happens if you break the rules?
If the programmer writes code that could potentially cause a memory leak or a buffer overflow, the TSA agent steps in. The Rust compiler simply refuses to build the program.
Wow, it just stops it right there.
It mathematically prevents the human error from ever making it into the final software. By rewriting the absolute foundational utilities of the operating system in Rust, Ubuntu is effectively locking the doors against entire classes of cyber attacks.
So while we are up on the surface enjoying our smooth Genome 50 desktop and playing with our new terminal time machine to undo our mistakes, the developers are quietly in the basement,
Rebuilding the foundation.
replacing the old, brittle, structural steel of the operating system with something vastly stronger.
They are building a fortress, and they need that rock-solid, highly secure foundation to handle the sheer weight of what the operating system has to shoulder next.
Which brings us to the intense new workloads the system is preparing for. We are talking about local AI.
A massive topic right now.
Huge. Ubuntu 26.04 features updated, native support for AI development, specifically mentioning CGA and ROCm frameworks.
These are the software layers that allow the OS to talk directly to the compute cores on a graphics card.
Right. Seeing that native support baked right into Resolute Raccoon is exactly what prompted Ang to explore setting up local AI inference.
Meaning, actually running an artificial intelligence model directly on your own physical machine sitting on your desk.
Rather than sending a text prompt up to a cloud server owned by a massive corporation and waiting for a response.
Exactly. You own the hardware, you run the model.
Here's where it gets really interesting. The hardware dilemma. It is an absolute chaotic mess for consumers trying to buy the right hardware to run these models.
It really is the Wild West right now.
Aang breaks down the AMD landscape beautifully in the post. If you are looking to get into this and you are on a budget, Aang identifies the RX 9060 graphics card with 8 GB of VRAM as your best entry point right now.
Which is a solid card.
But if you are looking for better value for your dollar, Aang says the older RX 6900 with 16 GB of VRAM is incredibly tempting. In fact, they call 16 GB the sweet spot for hobbyists.
It is a very specific, crucial distinction to make.
It's like buying a car for a cross-country road trip.
Huh?
Well, do you buy a brand new, highly efficient budget car, the RX 9060, that runs great but has a really small 8-gallon gas tank? Or do you look at the RX 6900?
I see where you're going.
It's a luxury vehicle, it's got a massive 16-gallon gas tank, but it is 2 generations old. The technology is aging.
That's the trade-off.
In fact, Aang points out that because the 6900 is 2 generations old, it might actually be smarter to just grab an RX 9060 XT instead to get that modern architecture.
It is a genuinely agonizing call for anyone building a system today.
Help me understand the physics of this bottleneck, though. Why is the VRAM the video RAM on the graphics card acting as the gas tank?
This raises an important question.
Why does the memory capacity matter more than just the raw speed of the processor chip?
Well, it comes down to how large language models actually function. When you run an AI locally, you cannot slowly stream the data from your standard hard drive.
Even an SSD?
Even the fastest solid-state drives are far too slow for the immense parallel processing required to generate natural language a word at a time.
So what does the graphics card do?
The graphics card needs the entire neural network loaded instantly into its own dedicated memory, the VRAM, to generate a response.
All at once?
Yes. If the AI's brain is physically too big to fit into the VRAM, the model just crashes. The car won't start.
It is a hard physical wall. Aang specifically notes that 16 GB of VRAM lets hobbyists comfortably run modern 13B to 14B models. That B stands for billion parameters.
And we should clarify what a parameter functionally is.
Yeah, please do.
A parameter isn't just a static data point. You can think of it as an individual neural connection in the AI's brain.
Okay.
A parameter holds the nuance, the vocabulary, the contextual weight of how one concept relates to another.
So more parameters means a smarter model.
Exactly.
Correct.
A 14 billion parameter model is incredibly smart and capable of sophisticated reasoning, but mathematically representing 14 billion individual connections takes up a massive amount of physical space in the VRAM.
Aang also mentions that with that same 16 GB sweet spot, you can run heavily quantized 27B or 30B models.
Right, quantization.
If a 30 billion parameter model is functionally too large for a 16 GB gas tank, what does quantized mean in this context?
Quantization is a fascinating workaround for the hardware bottleneck.
How does it work?
If a 30 billion parameter model, a much smarter, vastly larger brain, is simply too large to fit into 16 GB of VRAM, you can mathematically compress it.
You just shrink it.
Kind of.
Yeah.
Instead of storing a parameter connection as a highly precise 16-bit decimal-like 0.123456789, you round it off to an 8-bit integer like 0.12.
Oh, you literally chop off the decimals.
Yes. It saves half the memory space, but it makes the AI slightly less strictly accurate. The logic gets a little fuzzier.
So with that 16-gallon gas tank, you have a choice. You can either run a highly precise, smaller 14 billion parameter model, or you can run a compressed, slightly fuzzier, but ultimately much larger 30 billion parameter model.
Precisely. You have the breathing room to experiment. But there is a massive catch hanging over all of this.
What's the catch?
As Aang predicts at the end of their post, we are likely going to have to wait another 2 to 3 years for memory prices to stabilize before these local AI hardware setups become truly affordable for the average user.
That's a long wait.
The software is completely ready, but the hardware economics just have not caught up yet.
2 to 3 years feels like an absolute eternity in the tech world, but it makes total sense when you look at the landscape.
It really does.
The software in Ubuntu 26.04 is practically begging you to start AI training today, but the hardware market is still forcing you to choose between a tiny gas tank or a 2-generation-old used car just to get the job done.
The ambition of the operating system is actively outpacing the reality of the global supply chain.
So what does this all mean? We started this journey looking at a fresh coat of paint.
Geno MA50.
Right. Genome M50 smoothing out the visual user interface, hoping to finally fix that Nautilus file picker crash by untangling the messy intersection of visual layers and hard drive permissions, just so we can attach an email in peace.
That's a bold goal.
Then we dug into the deep plumbing, looking at kernel 7.0 acting as the new translation manual to get a MediaTek Wi-Fi adapter to hold a connection.
And then we moved into the terminal, where apt version 3.1 is proudly giving us super cow powers.
And a literal time machine to undo our broken dependencies, while simultaneously warning us not to rely on its output for automated scripting because robots need rigidly stable text.
Exactly. And we uncovered the massive quiet revolution happening underneath it all.
The Rust migration.
Foundational tools being entirely rewritten in Rust to mathematically guarantee memory safety, building a fortress with the borrow checker before the final switch in version 26.0.
All of which culminates in the system's ultimate readiness for the next era of computing, local AI.
Which is the big frontier.
Armed with updated SDA and RCM software layers, Resolute Raccoon is prepared to run those massive 14 billion parameter models, provided you can navigate the AMD hardware dilemma and afford the 16 gigabytes of VRAM required to bypass the physical bottleneck.
Whether you choose the budget entry RX 9060 or you hold out for that 16 GB sweet spot with the older RX 6900.
Right.
This is what is so compelling for you, the listener. Because whether you are a hardcore hardware hobbyist agonizing over GPU specifications and quantization rounding, or you are just an everyday user who is genuinely thrilled that your file picker no longer crashes when you try to save a family photo.
You are actively participating in this transition.
Yes. You're sitting at the keyboard of an operating system that is aggressively preparing for a massive technological leap.
The house is being renovated from the concrete foundation to the roof, all at the exact same time.
It is. And it leaves us with something incredibly profound to chew on.
Oh, I like profound.
If operating systems like Resolute Raccoon are quietly rebuilding their absolute core foundations in highly secure, memory-safe languages like Rust, while simultaneously baking in native, deep-level support for intense AI hardware.
Yeah.
What happens when the operating system itself becomes an AI?
Oh, wow. That is a wild thought.
Think about the trajectory. Will the desktop environments of the 2030s even require us to click through visual files and navigate folder structures like Nautilus?
Probably not.
Or will they use these heavily optimized, massive local models running on your graphics card to simply predict and generate the exact workflow you need the very moment you sit down at the keyboard?
That's mind-blowing.
We are so worried about patching the paint and the plumbing today, but tomorrow, the house might just learn how to rebuild itself around us.
A house that knows exactly what room you need before you even reach for the doorknob. And if the plumbing breaks, it just undoes the damage itself using its own intelligence.
Exactly.
We will leave you with that to ponder. Thanks for joining us, and we'll catch you on the next deep dive.